Let's make sure that we understand the difference between the binomial distribution and the geometric distribution. The binomial distribution is characterized by 1, a finite number of trials, and we'll call that number of trials n. Each trial has only 2 possible outcomes, and we'll call those outcomes a success and a failure. X is usually assigned as the number of successes out of n trials. Trials are independent. The outcome of one trial has no effect on the outcome of another trial. And the probability of a success, which we'll call P, is consistent from trial to trial. The characteristics of the geometric distribution are that each trial has only 2 possible outcomes, a success and a failure, so that's similar. The probability of a success, P, is consistent from trial to trial, that's similar. And the trials are independent, that's similar. But what's different is that we don't have a finite number of trials. The geometric distribution is used to find the probability that the first success, so the first time we have a success, would occur after the completion of a given number of trials. So let's look at this experiment. We're going to roll a single die 50 times and find the probability that the side with one spot would turn up at rest exactly 15 times. So let's look at then all of the characteristics of the binomial distribution. We have a finite number of trials, and that number of trials is 50. There are only 2 possible outcomes. We're either going to roll a 1 or not. And since this probability that we're finding has to do with rolling a 1, we will call that a success. Roll a 1. The trials are independent. Once we roll the die and then pick it up and roll it again, the outcome of the first trial has no bearing on the outcome of the second. The probability of a success is consistent from trial to trial. And that probability we give the letter P. And in this case, P would be 1/6. There is a 1 out of 6 chance that we would roll a 1 on any given roll of a die. So this probability that we're looking for is the probability that X is equal to 15. Now, we'll use the TI-84 calculator to find this, and the things that we're going to have when we do this are N, P, and X. In order to use this calculator to find this probability, we'll push second, variables, distributions, and then we'll go to, this time, binomial PDF, because we're finding a probability associated with one value of X. The number of trials was 50. P, the probability of a success, was a 1/6. And X was 15. So we'll hit paste. And if you're using an 83 or 84 calculator that doesn't have that menu prompt for putting in values, your syntax will be in this order: N, P, and then X, separated by these commas. So we'll hit enter, and we'll find that that probability is 0.008 if we round to 3 decimal places. Now let's look at the next experiment. We're going to roll a single die until the side with one spot turns up at rest. Find the probability that the first 1, so the first time we turn up a 1, would turn up on the 4th roll. Now we have only 2 possible outcomes. The probability of a success, P, is consistent from trial to trial. The trials are independent. But this time we do not have a finite number of trials. We're supposed to find the probability that if we roll this thing over and over, what's the probability that the first 1 would turn up on the fourth roll. So this then is going to be a geometric probability, where this, because we had a finite number of trials, we had a binomial probability. So to find this geometric probability, we'll push second, variables distributions, and then go over to geometric PDF. And we'll hit enter. And then we have P, the probability of a success. Well, it's the same. It's a sixth. Now the X value will be the number of trials that must occur before we wind up with our first success. And this time it was 4. So we'll hit paste. And if you're using an 83 or 84 calculator that does not use the menu to prompt you for these values, your syntax will be P and then X. And this probability turns out to be 0.096. Let's look at this next experiment. We're going to check gas caps during vehicle emissions tests. It is estimated that 14% of all vehicles from model years 1995 and older have leaking gas caps. Find the probability that out of 30 randomly selected vehicles from 1995 and older, exactly 5 would have leaky gas caps. So we have a finite number of trials. We're selecting 30 vehicles randomly from that time period. There are only 2 possible outcomes, and we'll let a success be finding a car with a leaky gas cap. The trials are independent. If we are selecting unrelated vehicles randomly and we find one with a leaky gas cap, there is no reason for us to believe that the next or the next or the next would also have a leaky gas cap. The probability of a success P is consistent from trial to trial. It is estimated that 14% of all vehicles have a leaky gas cap, so P is 0.14. So what we need then are N, P, and X. What's the question? We are to find the probability that out of 30 randomly selected vehicles, exactly 5 would have a leaky gas cap. So we're to find the probability that X is equal to 5. So we'll go to second, vars distr, and go to binomial PDF. P, the probability of a success, is 0.14. And we're to find the probability that exactly 5 have a leaky gas cap. And again, this syntax order is NPX. And so this probability will be 0.177 if we round to 3 decimal places. So because we had a finite number of trials, we have a binomial distribution. Let's look at the next question. Find the probability that the first leaking gas cap would be found on the 5th tested vehicle from a random selection of vehicles of model years 1995 and older. So in this case, we do not have a finite number of trials. All of the other conditions are satisfied. We only have 2 possible outcomes. Either a vehicle has a leaking gas cap or not. The trials are independent, and the probability of a success is consistent from trial to trial. That probability, P, is 0.14. And we're to find the probability that the first leaking gas cap would be found on the 5th tested vehicle. So here we have then a geometric distribution. So to find this probability, we'll hit second, variables distributions, and we'll go to the geometric PDF. P was 0.14, and we were to find the probability that the first vehicle with a leaking gas cap would be found on the 5th tested vehicle. Again, this syntax order is p and then x. And this probability turns out to be 0.077 if we round to 3 decimal places.